Thank you everyone for joining. I hope you're having a great re:Invent so far. This is a session on Agentic AI on financial services and insurance. We're going to double click on insurance underwriting as a use case for this talk. If you're working with your insurance customers, you would have heard that their underwriters process is largely manual. They spend a lot of time going through data to be able to make the decision. And we're going to talk about how we can transform that process for underwriters. My name is Bala KP. I'm a solutions architect, part of the financial services partner team. In my role, I work very closely with customers and partners in migrating complex business workflows on AWS. I'm co-presenting along with my colleagues Ayan Ray and Srinivas Pendiala. They will introduce themselves when they speak to their segment. Before we dive in, just wanted to quickly highlight some of the focus areas for the talk. I'll talk about how insurers are pivoting from a traditional assess and risk pricing model to become more partners in climate resilience. I'll talk about 4 key strategies insurers are adopting to improve their risk assessment methodologies. Then we'll reflect on some of the challenges that the underwriters are going through today. And we'll talk about how a multi-agent solution can help improve underwriters' experience. And we'll wrap this together by showing you a demo. And we also have a reference architecture that we wanted to share with you. And we'll also do a code walkthrough at the end of this talk. If you look at the sobering reality, this chart explains, this is all public information. This chart shows that the economic impact due to extreme weather-related events are going up every year. These events are no longer a rare phenomenon. It's basically a recurring financial risk for our industry. Just double-clicking on one recent event that happened early this year, the LA fires. This event alone cost about $250 billion in damages. And sadly, many of the insurers, they are not able to provide the right protection for their customers. And they're also sadly leaving some of these high-risk markets, leaving customers with very little options to protect their assets. Here are the 4 key strategies that insurers are adopting to improve their risk assessment strategies. Number 1, instead of providing a broad zip code-based pricing, now insurers are looking at providing granular-based pricing. So for example, let's take 2 buildings in the same street. One building might be closer to the water body, whereas the other building might be away from it. The building that is closer to the water body has a higher risk of flood-related damages. As a result, the premium for that building might be high. This is just one data point, but the insurers are looking at several data points so that they are able to provide very prescriptive pricing so that they can keep their premiums competitive in this market. Second, some of the insurers are also introducing coverage modifications in terms of exclusions. Like for example, they are excluding wildfire-related coverages or flood-related coverages. And third, LA fires is an example. Some of the insurers are even re-looking at their business strategy and even thinking that they're not able to provide the right protection, and sadly, they are even exiting some of these high-risk markets. And finally, insurers are also providing remediation recommendations as part of providing underwriting code. And if the customers are able to implement those remediations, they are incentivizing them in the form of premium discounts. Let's look at the current process of underwriters, more like a day in a life of a risk assessment for an underwriter. Once the underwriter receives the application through the submissions process, either through a broker or directly from a customer, they will have to look at series of data points to make sure that they evaluate the risk across all segments. Like for instance, once the application comes in, they'll have to make sure that all the information related to the property, the information surrounding the property, all that information are available so that they can make an informed risk assessment. Initially, they need to first figure out whether the specific property is even considered as an approved asset class for an insurance carrier. So they have to look at the underwriting guide to ensure that they are only working on approved asset classes. Then they also need to look at whether this property has any historical losses or claims. Now they have to look at another system to be able to look at, okay, what are all the historical losses and claims. They have to look at data sources from NAIC or clue reports or loss run reports to be able to determine if there are any historical claims on that. Now, depending upon the location or area that this property is, Now they also need to look at what are all the property-specific heuristics, like what is the construction type, what is the roof age, how far is the fire hydrant from the building, what are all the proximity locations around that building. So now they need to look at the various property-related information. Typically, these informations are scattered across underwriting workbenches, either in structured or unstructured data formats in terms of inspection reports. Now they have to manually review all that and individually synthesize all that risks. And if they need to assess weather-related risks, now they need to look at another data source or potentially another third-party application to understand what is the weather pattern in that specific area. It could be hurricane, wildfires, snowstorm, and so on. Now they have to look at another data source to be able to do that. Likewise, this is by no means this is a complete list. This is just a fraction of data sets that I'm just showing here, but depending upon the type of assets and the type of property in that specific location, typically they look at anywhere between 15 to 20 different systems to be able to ingest all that information and individually synthesize that information in order to understand the cohesive risk posture of that specific property and then decide what would be the appropriate pricing and all that stuff. So it takes a lot of manual time for an underwriter to go through all these things. And if you see, most of the time they're not doing, most of their time is taken by just pure data hunting, data cleaning, and individual synthesis. And they have very less time to do their core job, which is understanding the nuances between the risks and effectively provide the right judgment whether they have to underwrite the property or not, and based on that, what would be the appropriate premiums. As a result of this, several insurance carriers are basically only working on fraction of submissions because they do not have time to go through the entire submission process. As a result, they are basically losing some of their customers. Let's see how an agentic AI solution can help improve this experience for an underwriter. The process is very similar, but once the submission process kicks in, now the agents go to work in terms of collecting the data from based on the approved data sources. The same process, understanding what is the first party, third party claims, going to the property heuristics, going to the environment hazards. So the agents basically collect all that information and provide a synthesized analysis to the underwriter along with citations from the trusted sources. That way, the underwriter is able to quickly review the risks based on all the data that is collected by the agents, and now they have more time to do their core underwriting expertise rather than spending a lot of time going through all the data hunting and so on. So let's see how we can build this application and run it at production scale on AWS. For that, let me invite my colleague Ayan back to the stage to deep dive further on this.
Thanks, Bala. My name is Ayan Ray, and I am a Gen AI tech lead here at AWS. And in my present role, I work with infrastructure ISV partners of AWS to build a better together generative AI story to help our joint customers. And today, I'll be talking about Agentic AI primitives, Strands agents, and Amazon Bedrock Agent Core. So AI agents are truly transforming the way we work. It's solving very complex problems across a variety of industries, including the insurance underwriting industry. Now, the challenge in each of these industries are different from each other. For example, in the insurance underwriting industry, as Bala was speaking, the data resides in different disparate systems. So you need to manually curate the data, synthesize the data, calculate the individual risk scores like the fire risk, property risk, flood risk, then assign weights to these individual risk scores to calculate a cumulative risk score. Now, this process has been all manual until very recently. But now, with the help of an AI agent, you can significantly enhance the productivity of an insurance underwriter. So the question is, what is this AI agent? So an AI agent is an autonomous software system that can reason, plan, and most importantly, take actions to accomplish a goal that has been assigned to it in a digital or physical space. And an AI agent is built from a common set of primitives. Obviously, large language model is at its core, and it relies on large language model for reasoning, planning, tool calling, and generation capabilities. Data gives it context. Tools allows it to interact with external systems, either to take actions or to retrieve data. Memory keeps track of the conversations, both immediate and long-term. System prompts define the behavior of the agent. Guardrails ensure privacy, security, compliance. And last but not the least, observability helps us to measure the performance of an AI agent and improve. And all of these primitives are usually stitched together using an Agentic AI framework. And the ecosystem offers many: LangGraph, LangChain, Crew AI, Llama Index. And we also have launched Strands agents, an open source Python SDK that helps you to build AI agents with just few lines of code. It's already very popular in the developer community, with more than 5 million downloads till date within just few months of launch. And one of the reasons it's so popular in the developer community is because it's so simple to use. You can build your first AI agent with just 4 lines of code. It eliminates most of the deterministic, complex Agentic AI orchestration steps. Rather, it is model-driven. It relies on the power of state-of-the-art large language models to do most of the reasoning, planning, calling tool, and reflect. At Amazon, we strongly believe in eating our own dog food. Amazon Q developer team is a perfect example. They have been using Strands agents to launch AI features at a blazing fast pace. What used to take them months before is now only taking weeks. A great validation for Strands solving real-world use cases. Here is a simple example of how you can build your first AI agent, as I said, with just 4 lines of code. Simply import the agent class from Strands package, import a tool of your choice, initialize the agent with or without a tool, and invoke the agent. If you don't explicitly specify a foundation model, like in this case, by default, it chooses Anthropic Claude Sonnet 4 via Amazon Bedrock. But you can choose any of the other high-performing foundation models from leading AI companies and Amazon to build your Agentic AI application using Strands. We also want to meet customers where they are. That is why you are not limited to only Amazon Bedrock foundation models. Rather, you can choose models hosted by other LLM providers, be it Azure OpenAI, Google Gemini, or others. Strands also comes with a pre-built set of tools for knowledge base, memory, web search, calling external APIs. These tools helps you with the most common Agentic AI use cases. But the digital space is huge, and there are so many applications out there, and there are so many agents that want to access these applications. So clearly we have an M cross N problem. And Model Context Protocol, or MCP, provides a standardized way for AI agents to access these tools. And in Strands agents, we have built-in support for MCP. You can connect to your local MCP server using STDIO or to your remote MCP server either through HTTP streaming or server-sent events. But not all applications have an MCP server yet. For those, you can create your own custom tool. Simply import the tool function from Strands package, write your own custom function, and use the tool decorator to register your custom function as an AI tool and make it available to your AI agent. Observability refers to the ability to measure the performance and behavior of an AI agent. And I'm not talking about just the standard application telemetry. I'm talking about the AI-specific signals like model invocations, reasoning behavior, tool execution trace. In Strands agents, we have built-in observability. We also support open telemetry. That means you can visualize the entire agentic AI trace in the choice of your observability tool as long as it supports open telemetry. So with Strands agents, it provides with all the building blocks that is required to build an end-to-end agentic AI applications. So with Strands agents, you can build that insurance underwriting agent MVP in days and not months, right? But building is only one part of the agentic AI journey. Getting agents to production is still too hard. And while I work with customers, I see many fantastic ideas still stuck in the POC phase and is not moving to production. And that's the reason we launched. And when I talk to these customers, there are a few common concerns that they always tell to us, right? I feel, for example, when I work with the insurance underwriting industry, I feel that the excitement around AI agents is real, but so are the concerns. The concerns that they always tell us about are, first of all, agentic AI requirements are diverse. At times, you want the AI agent to be ready and responding in near real time, like the contact center agents. In that situation, you cannot afford to have those long cold start delays. But there are times when you want the AI agent to be running for long hours, maybe doing PhD level research, like the deep research agents. And you also want the AI agent to be retaining all the context for these extended hours. But the challenge is common serverless frameworks are stateless, and they time out at 15 minutes or around that range. This variance and diversity in workloads makes provisioning of compute resources a difficult problem. And if you're over-provisioning for the peak demand, you know how that goes. Costs can easily spiral up. Also, the stochastic nature of AI agents makes security a complex problem than traditional applications. We need strong session isolation, and process level isolation is not enough. Customers also struggle with the identity and access management of AI agents, particularly because the AI agents need to act on their behalf and access sensitive systems. Customers also need to build MCP servers, and while doing so, they need to convert their existing APIs into MCP servers, manage the infrastructure corresponding to it, build intelligent tool discovery, build the identity and access management corresponding to it, and they need to continue supporting newer protocols from MCP to A2A and beyond, whatever is coming up. Then there's the question of transparency. Can I trust this AI agent? Is this AI agent taking the right decisions or not? And how do I address those bottlenecks and errors? And to address all of these questions, we launched Amazon Bedrock Agent Core, which is a set of services that eliminates the undifferentiated heavy lifting of building and managing specialized infrastructure for agentic AI workloads. It works with any framework, any model, and any protocol. The first service in this list is Amazon Bedrock Agent Core Runtime, which is a secure serverless runtime to deploy and run AI agents. It works with any framework, LangGraph, Crew AI, Strands agents, any protocol, MCP, A2A, and any model in or outside of Amazon Bedrock. It is particularly designed for agentic AI workloads with long runtime windows, with true session isolation, built-in identity and access management system, support for large payloads, and many more. I'll come back to Agent Core Runtime and cover it in a bit more depth, but before that, let me touch upon the other primitives. Next up is Agent Core Identity, which provides an identity and access management system for agentic AI applications. So with Agent Core Identity, you can securely access AWS resources or third-party applications. It is compatible with the common identity providers like Okta, Microsoft Entra, AWS Cognito. It also minimizes the consent fatigue while accessing third-party applications by using a secure vault to store the workload access token. For example, the insurance underwriting agent. It is a combination of multiple different agents, like for document processing, for risk calculation, for policy generation. So each of these agents' role, permission, and data boundaries can be enforced using Agent Core identity. Next up is Agent Core Gateway, which provides an easy way for developers to build, deploy, discover, and connect to AI tools. With Agent Core Gateway, you can easily connect to Lambda function. You can easily convert your existing APIs, Lambda functions, and existing services to MCP compatible tools and make it available to the AI agents. It supports OpenAPI, Smithy, and Lambda as input types. It also has one-click integration with popular SaaS applications like Salesforce, Jira, Zendesk, Asana, and many more. So Agent Core Gateway eliminates those months of custom code deployment and development that is required for your AI agent to access the tools. For example, in the insurance underwriting agent, it needs to access a third-party REST API for finding out what is the flood risk corresponding to a particular property. And now, this can be easily done using Agent Core Gateway. Next up is Agent Core Memory, which is a fully managed service that keeps track of both short and long-term conversations so that the AI agent can deliver more intelligent, personalized, and context-aware responses. Like in the insurance underwriting agent example, it is not just one shot. There are multiple interactions happening across multiple invocations of the process. Now, you can use Agent Core Memory to keep track of all these conversations to form a holistic risk profile corresponding to a particular property so that you don't have to process all the information every time. Agent Core also provides tools for browser use and for code interpretation. Next up, I want to cover Agent Core Observability, which provides an easy way for us to monitor, debug, and visualize the entire agentic trace. It provides a visibility into the end-to-end agentic AI trace, including the intermediate output, model invocations, reasoning behavior, tool usage, etc. Now, at some point of time, if you are asked a question, why did you rate any company 1 as high risk in your policy generation process, the entire agentic AI trace is available to you. So there's no hidden reasoning and no guesswork involved. And this is a reference architecture of how all of these services comes together to form an end-to-end agentic AI applications that is production ready. I'll come back to I'll double click on Agent Core Runtime and highlight some of its differentiated features. First of all, it provides true session isolation. And it is not just process level isolation. It is a micro VM level isolation. Let me explain that with an example. For example, Insurance Underwriter 1 trying to calculate the policy of any company 1 using an underwriting agent that is hosted on Agent Core Runtime. A dedicated micro VM isolated session is spun up for this user session. Maybe at the same time or later, another underwriter tries to use the same agent hosted on Agent Core Runtime and tries to calculate policy for any company 2. A separate micro VM is spun up for that user session. So there is no data contamination between these two customer processing. Now, each of these micro VMs leverages a technology called Firecracker micro VMs, which are known for their exceptionally fast boot times. That means they can spin up these micro VMs very fast. And this is equally applicable even when there's a surge in traffic. Now, Agent Core Runtime also supports long-running workloads of the order of 8 hours, up to a maximum of 8 hours. And not only that, it can retain all the context within this 8-hour window. So you can just do deep research agents, like the insurance underwriting is a complex process. There's a lot of things going on, but it can retain all the context within that maximum of 8-hour window. Agent Core Runtime also supports large payloads as high as 100 MB in size. That means you can work with large image files, audio files, and video files, and that is equally applicable both for request and response payloads. So with Agent Core Runtime, you can transform your local agentic AI code into cloud-native deployment with just few lines of code, irrespective of the framework that you are using. Simply import the Bedrock Agent Core app class from Bedrock_Agent Core package, initialize the app, define an entry point using the app.entryPoint decorator. This is where your actual agentic AI business logic goes, and then run the application using app.run. What happens under the hood is your agent's code, dependencies, and configurations are packaged into an ARM64 compatible Docker container image. It is then pushed to Amazon ECR repository. Agent Core Runtime spins up a dedicated micro VM referencing that container image. It creates a V1 of the agent using the configurations at that point of time. It also creates a default endpoint, which is a stable, referenceable, and addressable endpoint to invoke your AI agent. And the default endpoint always references to the latest version of the AI agent. So the agent is complete when its status turns into ready. At this point of time, it is ready to request and process responses. When the user invokes the AI agent, Agent Core Runtime takes over. It spins up a dedicated micro VM corresponding to that user session, and within that micro VM, it executes the app.entryPoint decorated function, which comprises of your business logic, and it executes that. So now with Strands agents and Amazon Bedrock Agent Core, you can build and deploy your agentic AI applications. Now I'll invite Srini on stage to demonstrate that in action.
Thank you so much, Ann. Really appreciate that. Are you guys having fun so far? If you can, give me a thumbs up. We're going to make it even more exciting with a demo here. We'll start that with a architecture blueprint here, right? As the underwriters get the submissions, right? Once they upload into the system, a bunch of agents kick in. And the design pattern that we have actually used here to orchestrate this is called a swarm design pattern. Swarm design pattern is nothing but it's basically a multi-agent collaborative design pattern. What it means is each of these agents enjoy their own, they're very completely autonomous, enjoy their own freedom to actually do their job, and then together they actually go after a specific task and then achieve that task. Now let's take one step back. As Ayan has already dived deep on this, what really makes an agent, right? It's three components. Number one is the system task, the task that you really want this agent to achieve, right? Typically you express that in the form of a system prompt. Then the second thing that you need is for any agent to do anything, it requires tools, right? So that's the tool set that you actually provide to the agent itself. Then of course, all of this happens without the main ingredient, which is basically the model itself, the foundation models. And where do you get these foundation models from? Again, Amazon Bedrock. Amazon Bedrock gives the customers a plethora of choices of foundation models that you can leverage and get the job done, right? So that's an agent. So as you can see here, we have these multiple agents running together. Now, under the hood of these agents, as they are achieving their tasks, under the hood again, they are leveraging different services. For example, if you look at the geocoder agent right there, the geocoder agent is, what it's doing is basically it's taking, for example, a physical address, translating that physical address into a longitude and latitude, right? The process is called geocoding, right? And under the hood, it's actually using the tool there, and under the hood again, it's using Amazon location service to get the job done. Again, you have, for example, the other agent that I could talk about is weather agent, right? And the weather agent again is using tools, and the tool is what it again doing is it's going to a web service, NOAA website, and actually gathering all the climate information for that specific geographical location. Like that, you also have a historical claims agent. As the name suggests, it gets into your specific data sources where you're persisting your historical claims data for a specific geographical location and gets all of that information. And then, of course, you have the synthesis agent and underwriting agent. The underwriting agent finally gets all the data from all these different other agents that they have worked together and then makes a recommendation. Now, one of the most important things to keep in mind is while these virtual agents are doing their job, it's very important to understand that the human in the loop is a very important factor here. These are all like a tools that are actually provided to the actual underwriter, the human, and he or she, they actually make the final decision about the submission that they received, right? So it's pretty simple. And as I showed, Amazon Bedrock, with all the model choices that you get from the different innovative AI companies like Anthropic, Meta, including Amazon, Nova models, right? So you can actually leverage any of those models to get all these intra-agentic communications, and the intelligence built into it is all being supplied by the foundation models from Amazon Bedrock. Once all of this happens, the response goes back to the underwriter, and the underwriter reviews that in a PDF format or whatever, and then basically makes a decision on the submission. So that's pretty easy blueprint that we can look at. So now let's look at the actual application itself that we built. So here I am. It's basically a simple Streamlit app here, right? So let's look at the experience from the end user point of view. So it's actually designed as like a step-by-step wizard, right? So the underwriter, think of yourself, put yourself in the shoes of an underwriter, and now you're answering a specific questions. What is the property address that you need to look at this, right? So go ahead and give a property. It's a specific address in Houston, Texas. I click next. What's the type of commercial property is this? Is this a residential property? Is this a retail store? Is this a hotel, right? Whatever it is, right? So I'm going to choose that. And then what is the estimated property value? I threw some number, some 800K, whatever. And then do you have to evaluate this? Yeah, so it's asking a bunch of questions, interesting questions. Like, do you want to look at the weather data for this specific location? Do you know if this specific address is a legit address, right? Does that place really exist on the Earth planet, right? Things of that nature. So once you make all these selections, right? Do you want to look at the satellite imagery analysis, right? Do you want to look at for a specific zip code? In this case, I chose Houston, Texas, right? For that specific location. Do you want to look at the claims history in the past, right? And all of that. Once you make all these decisions, those decisions that you did on the UI is basically going to drive the agents that are going to be engaged in this overall task. As you can see, boom, all the agents get started, and you can visually see things happening. But I'm going to focus on the under the hood thing because we really want to see what's going on, right? So here you go. As you can see here, the first agent, geocode address agent, right? Remember what it does? It takes a physical address, translates that into a longitude and latitude, right? So it did actually do that job. So you can see that there's a latitude and longitude there. I don't know if I can focus here. Yeah, that's fine. And then it also does location analysis, like in terms of this is the neighborhood. In this case, it's downtown Houston. It's a classification. It's an urban area, right? What does the emergency response infrastructure looks like? What are the key risk factors if this submission were to be, approved, for that specific location? How would it would look like? It's making all that analysis there, right? And then, yeah, as it highlights those. Now, here's another thing. I want to double ensure that this is a legit location. So I opened up Google Maps here, just put that longitude and latitude, and it indeed matches to Houston, Texas, right? So that is downtown Houston. And we can look at all the information that I already mentioned. Right, geographic factors. Now here is the, remember I talked about the swarm design pattern, where all these agents are working together? You can see that there is a tool number 2, handoff to agent. So there is a perfect handoff. As soon as the tool 1 is done, it's actually handing off the information to the next agent here, in this case, as I'm highlighting there, right? And in this case, it's actually the weather risk assessment. Again, it takes the location. It does goes to the web service, a NOAA web service, does a bunch of REST API calls, gets all that information for you, and it starts analyzing, right? You can see, when was the last historical events that happened from the weather standpoint. You can see the major flood happened there, the minor floods, severe tornadoes happening, and it does a high-level distribution of these risks for each of these different weather events. And it also, senses a little bit of on the seasonal risk patterns too. In spring, what happened? In summer, what happened? All that. And interestingly, it also gets into the realm of how this could actually, has any insurance implications on it. Specifically, when it comes to the premium structuring aspect itself. Again, the handoff to the agent. The next agent is happening, right? So it's beautifully, all these agents are coming together. And believe it or not, as Ian has already highlighted, it's just one single line in Strands SDK. I would encourage all of you. I know many of you may be a good, big, fans of Crew AI or LangGraph or Llama Index, and you may be thinking that I may be a little bit more biased here, but I would encourage all of you to fall in love with Strands SDK too. It's super, super easy. If you're a Python developer, easy, easy. If I can do it, anybody can do it. So the handoff is happening here. Now, where are we? So now we are looking at claims analysis itself. So now for this, under the hood, what we are doing is the claims, historical claims agent is leveraging, in this case, RDS, relational data store from Amazon. But you can actually use any data source, right? So again, looking at all the claims for that specific area, it's looking at the risk implications, right? And then, again, it does an analysis, and interestingly, it gets into the realm of scoring those, for each of those risks that you're looking at. That's the claims history. It's very interesting to see how what the average claim amount seems to be for that specific area in Houston downtown. Again, the overall risk factor, and again, the handoff. This is like an orchestra, right? All the agents are coming together, and they're kind of doing the job for us. Now comes the interesting part, which is the underwriting decision itself. Remember all the different agents that I was talking about, right? They all, like, once they do their job and finally gives to that underwriting agent, right? That underwriting agent is actually going to make a decision. Again, this is the virtual agent that's doing it, but in practicality, from all pragmatic standpoint, right? We want the actual human to really review this and actually make that decision. So in this case, interestingly, it gives that it basically considers that as a conditional approval and what the conditions should be. In this case, it says like mandatory flood insurance because it's Texas has a lot of flooding, so you might want to have flood insurance in place. You want to have installation of water detection systems in place. Hurricane preparedness is also needed. All those. Once you have those documentation, the human underwriter can actually make that decision as a conditional approval. And it interestingly gets into even the breakdown of the actual premium itself, right? It gives how it should structure what the base price property premium should be, what the flood risk premium should be, and all that. It's quite an interesting scenario here. And then it gives its rationale. This is the reason why I think it should happen. So what we have seen under the hood using the CLI, right? So I'm going to show the same thing on the UI here, the user interface experience. Whatever that you already seen, it's all now visually presented for you. Those are the risk summaries. And you can actually see each of these agents as they are executing what the inputs are, what the outputs are, how the tools are getting invoked, and how each of these tools are exchanging the data among themselves. In this case, it happens to be a JSON format, right? You can see the recorder tool, the weather tool, right? The imagery tool, the claims tool. So all the data, how each of these tools are exchanging that. And then if I double click on that, again you get the analysis itself from each of these weather data, each of these agents, I mean. And the output from the agents is also captured there, as you can see. Right? And then the decision is conditional approval, and along with the risk pricing breakdown that it already showed, that we already discussed, right? So it becomes very interesting. It's again, it gives you also a visualization aspect of it. What's the risk score? You see what the overall risk levels could be. It's actually compares what the industry standard is and how this specific location would look like, right? So those are the interesting visualizations that you get out of this. And again, the idea here is dream big. Make these tools and bring your innovation and make this happen, right? And of course, here again you can actually export that as a PDF. If you want to shoot that out to another approver, you can do that. But the underwriter basically looks at all of this information and then reviews this information. And if he or she has a difference of opinion, they would document that aspect of it and then basically go from there. So now let's do a code walkthrough. Right? This is, as you can see, line number 4 there. I'm leveraging Strands SDK, and I'm actually using a bunch of Python libraries there. I'm importing Bedrock model there. And remember, I was talking about swarm pattern. Even though for the readability aspect, I've kind of split that into line number 38 through 45, but it's one single line of code. Simple line of code. Strands SDK, swarm, boom. You tell these are my agents, create a pattern. Right? It's so easy. And each of these agents, so for example, I'm highlighting their geocoder agent. The agent is created using, again, remember 3 things that I said? An agent makes up 3 things. System prompt, the task you're throwing at it. Second one is the foundation model itself. And the third thing is what? Tools. Right? So that's exactly precisely what it is. Line number 49 is the name of the agent. Line number 50 is the model itself, and in this case, we are getting the model from the Amazon Bedrock, right? And the system prompt, you're throwing a task at it. And then finally the tools. So I provided the tools on line number 88. That's it. It's as simple as creating an agent. And once you have defined all these agents, create a swarm pattern out of it, and the rest of the magic happens for you. I'm highlighting here, for example, just to give an example, a taste of what it is, right? In this case, the tool that we're using is, I'm using the Boto 3 client. How many of you used the Boto 3 clients? If you have used it, raise your hand. There you go. So simple Python code to invoke Amazon location services here. Like Ian has already highlighted, bring your logic, bring your business application logic. And using simple decorators, like tool and all, you're in the game. You're in the game. Right, so I'm just showing an example of how Amazon location service is getting used. I created an index. I'm going to use that index, and boom, you're basically geocoding a physical address that you're throwing at it. That's the swarm pattern, right? Now let's look at the agent core. Ian really zoomed into agent core. Long story short, if you need to productionize your agents, you need agent core. And to make it super, super easy, even from the developer standpoint, right? We give a self-starter kit, and it's basically a CLI experience using a bunch of commands. You can take, imagine yourself as a developer who actually just coded, right? Using those commands, right there, agent core configure. It gives you all the details of how you can configure an agent on agent core, right? You can define the entry point, you can define the container runtime and all of that. So I'll zoom in here a little bit here, real quick. If you see on the very top, right, I said agent core configure, give it a name, and minus E is basically the entry point for you may have a complex application logic, but you always have an entry point where you want the application logic to kickstart, right? So that's minus E entry point. And then, of course, it's written in Python, so you're saying, hey, requirements.txt is all the dependencies that my application needs to be running on, right? And of course, I'm saying region is my US West in this case. Once you do that, the starter kit does the rest of the magic for you. It takes the application code from your developer laptop experience, ships that, containerizes that, and ships the containerized bits to ECR, Elastic Container Registry. And then all you got to do is then launch. Hey, agent core, my code is ready. It's containerized. It's now in the ECR. Agent core launch. That's it. And it launches. And it gives you, not only that, it does launch, it basically gives you, it creates all the cloud resources needed to run your agents securely and deploying it at an enterprise level, right, for production adoption itself, right? So you can see all that steps happening there. Once everything is done, all the plumbing is done for you. All you got to say is, hey, go invoke it, just to kind of test it here real quick, right? Instead of saying hello, we're really bored of hello world applications, right? So we're going to remove that hello and then say, hey, go do a risk assessment for the property at the same Houston address that we were doing it. So in the previous section of this presentation, right, we did that using a web console, because not everybody is technical, right? We actually, in fact, not everybody need to be technical. We want this to be in the hands of the actual users, in this case, underwriters, right? So we gave them the web console, user interface experience, but I kind of shifted the gears here and I'm getting into the developer experience here. But it's the same thing, whether you invoke from agent core from the CLI, whether you invoke that using the user interface itself, under the hood, it's all the same logic that's getting executed, right? So the same application that I've showed, I deployed that right in front of your eyes on agent core. And boom, you get the same response, right? Now this is the Agent Core web console experience again, the same thing, but how you can do that from the UI itself. You go click on Agent Runtime, you click on a host and agent, but in this case, remember we did the starter toolkit, it's all ready for you. You can actually look at that. You can remember it containerized it and uploaded it to the ECR, Elastic Container Registry. That's what I'm showing there. The latest, think of it like from the DevOps standpoint, right? You know, as you're building it in your GitHub, as you're checking in, you can actually automate all of this process, and you're shipping your Agentic AI applications faster. Now, this is the beauty of this. I clicked on the Agent Core by default with auto instrumentation, with zero code. You have end-to-end observability right out of the box. You have the security right out of the box. You got the, Ian talked about, memory aspect of it, which is right out of the box. You get, in fact, everything, all the enterprise tools, right out of the box. It makes super easy for you to craft your next generation, Agentic AI applications. So I'm actually looking at here into a log here, just to see, if I invoke a specific, prompt there, I took the same prompt as a sandbox test endpoint, right? I clicked on it. I put that as an input there, click run, it generates the output. There you go, it's the same output that you get from the web console, you do that from the CLI, you do it as a business user from the web user interface experience also, sorry. So I've shown the same one app, how you develop it, how you ship it, how you productionize it for your enterprise adoption through different means. You've seen all that right now. And, you can look at the logs. CloudWatch really gives you a complete breakdown of each of these. What models have been used? What were my inputs? What the output I got? And you can actually see all of that. And Agent Core completely now supports OTel, Open Telemetry. So you can, like Ian has already emphasized on this, you can use any observability tool that you have in enterprise, and you can actually get all this and more deeper insights, if you want, through these tools. Right, I'm also showing some metrics here. So, in essence, what we have seen is we have looked at the architecture. We have looked at the. So we have looked at the architecture. By the way, please take a picture of this. This is the reference architecture. Feel free to actually grab one, because this could be an inspiration for the real dream that you're dreaming of, how you want to really leverage your enterprise data sets and build more on this, right? So feel free to take a picture of this. What we have done so far is we looked at the reference architecture. We looked at the process of how this would look like from the business end user standpoint. Then we shifted the gears and looked at from the developer standpoint, how would you develop this? We did a code walkthrough, right? Then we deployed this using the starter kit, right? And then what we've done is, then we also looked at the web console, AWS web console experience of it and how you can deploy it and all that. And then finally, we are here. This is the reference architecture that you can look at, right? So I want you all to leave with this. AI revolution is happening right now, right? It's no more an option for any one of us to say, hey, you know what, I don't have a AI adoption strategy. Let me think through this. No, it's happening. It's happening, right? So I want you all to think, challenge yourself. Humbly, I want to request to challenge yourself how I can take these assets, how I can take these tools that we're building as a customer, as a partner, right? Take these tools and build these innovative applications on this, right? So there's a lot of things happening in the financial services industry itself, be it in the banking, be it in the capital markets, payments. Of course, we zoomed on insurance part of it. So please take, again, a picture of this. These are the QR codes for all the resources that we already have. Feel free to look at these GitHub repos, look at these resources. It's, again, serves only as an impetus for you to think big, to dream big, and leverage AI technologies from AWS, right? So here's another bunch of resources, please. Please take a moment to actually, again, capture using your cameras. These are the other additional recommendation sessions. I would strongly encourage, please take a time, take again a picture of this. If you want to zoom more on this, right? For example, the third session, it's happening at 4 p.m. today. The best practices with Amazon Bedrock Agent Core. Whatever Ian mentioned, whatever Bala talked about, whatever we have actually demonstrated for you all, you can actually zoom in more as at 4 p.m. Win again the same place. So please take a picture of that too. With that, I would please encourage all of you to, if there's a way you can actually leave feedback for all of us, please. We are here. At the end of the day, we are here at AWS. We strongly believe in customer obsession. We actually serve customers to make sure that they are benefiting from their cloud investments, the AI investments that they're doing. So we strongly subscribe to that. Customer is #1 priority for us. So please feel free to leverage these tools. Please feel free to give us more feedback so that we can better serve you all. So if you have any more questions on this, we will be right there, all three of us. Ian, by the way, is a subject matter expert on Agentic AI. Bala is a subject SME on the financial services on the side, and I kind of fit myself in between both of them. So feel free to ask any of us, and I really, really thank you all, and please kindly accept my gratitude for giving your valuable time on this presentation. Thank you, sir. Thank you all.